With this video, I'm now going to work with the binomial probability formula and tackling problem number 21. You'll see that I've already circled the important information from problem 21. Problem 21 tells us if the number of blood donors is n equals 8. That means there are going to be 8 trials. We're going to find the probability that the number with group O blood is x equals 3. That means there will be exactly 3 successful outcomes. We will get 3 individuals with group O blood. Now the third item is in our directions, and that is our 45%. It tells us that 45% of the individuals have group O blood. That is our probability of a success within one trial. So taking these values, we're now going to move over to our paper. Here I have outlined our formula and a few pieces of information about our variables. Remember, n is the number of trials, x is the number of successes among those trials, and p is the probability of success in any one trial. Q is then the failure probability. So from our problem itself, we can identify that n was 8, x equals 3, and our probability was 0.45 for 45%. Now to calculate our Q, simple calculation, we just need to take the value of 1, that means all of the possible combinations, minus 0.45, that's our successes, and that will get our failure probability, 0.55. Now we have our 4 variables with which to plug into our formula, and you'll see that here. Oh, it's so beautiful, isn't it? All right, hang in there with me. Probability of x equals 8 factorial all over our n minus x, or 8 minus 3 factorial, times our x factorial, in this case 3 factorial, then times our probability of a success raised to the power of x, times our failure probability raised to the power of n minus x, or 8 minus 3. Once we have these items into our formula, we just need to do some plugging and chugging with the order of operations. The biggest mistake that I see is people tackle this first fraction and they forget to incorporate these at the end of the problem. They are, in a sense, forgotten. So you want to make sure you bring those along through your work. So the next step that I did was to calculate 8 factorial. And we have 8 minus 3, giving us 5 factorial. 3 factorial comes down. And I also simplified my exponent on my failure probability. To simplify this fraction, I did do our factorial calculations. 5 factorial is 120. 3 factorial is 6. And now to simplify this denominator even further, I just need to perform 120 times 6, which will get me 720. So it's already looking a bit nicer. So from here, I simply need to divide my numerator by my denominator. And in this case, it actually comes out very nicely as a 56. And then I also need to calculate the approximate decimal values for our probabilities raised to the appropriate powers. Now you'll see here, here's my 56 from our first fraction. 0.45 raised to the third power is 0.091125. And 0.55 raised to the fifth power is 0.05032844. Now you do not need to maintain quite so many decimal points, but I wanted to show them to you in this example. I would maintain probably around 4 or 5 decimal places just to maintain the integrity of the problem. More is always better, but they can get a little overwhelming with all those decimal points. Now, once we multiply, that's our last step here, is to simply multiply our 3 values together to get our final probability. Now, I have written this using 4 decimal places. The reason being is my probabilities have 2 decimal places. That means my final answer needs to be rounded to 1 more than that, which is 3 decimal places. In this case, Here's my third decimal place. I look to the right. This number is a 5 or higher, which tells me the 6 needs to round up. And so my final answer is 0.257. And that is how you will do problem 21, paper and pencil version.